Hello and welcome to this lecture where we are going to start the implementation of tracking algorithms using OpenCV library. Just a reminder that last lecture we created this file test OpenCV just to make sure that the library was successfully installed. Now let's create a new file. I will click New Python File. And the name of the file will be single tracking. The first goal is to select and track only one object. Let's import the libraries. Import CV2. This is the OpenCV library. Import sys to have access to some functions of the operational system. From random import randint to generate random numbers. Now I will create the first variable, tracker type, in the format of a list. When we open and close brackets, we are defining a list in Python. And the goal is to define here the name of each one of the algorithms. The first one is the boosting. The next one, MIL, KCF, the next one, TLD, median flow, MUS, and finally CSRT. This is the algorithms that we saw last lectures. And we are going to use this list to define the algorithm that we are going to use. Let's create another variable, tracker type. This first one, I will change the name for tracker types. And in this other variable, we are going to select one of these algorithms. Let's access, for example, tracker types in position 0. Let's print tracker type. We can run this code just to perform the first test. See that when we put number 0, we get the name, which is boosting. Indexes in Python starts from 0. Boosting is the algorithm 0. MIL is the algorithm number 1. KCF algorithm number 2, and so on. Let's put here 3. Run this code again. See that the result is TLD, position 0, 1, 2, 3. We are going to use both variables in order to indicate the algorithm we are going to perform the tests. Let's implement an if statement. If tracker type equals boosting, then we are going to create the object. I will create this other variable, tracker equals CV2. Let's access this package, legacy.tracker boosting _ create. This is the way we can create each one of the algorithms. We can print the tracker, but first let's just change it here to position 0, which is the boosting algorithm. Let's run this code. See here that we have this information, tracker boosting, and these letters here indicate that the object was successfully created. So now we have a boosting tracker in this variable here. This letter represents the address that the object is occupying in the memory of the operational system. Now we need to perform other if statements to create the other algorithms. Elif tracker type equals MIL, then the tracker will be equal to CV2 legacy.tracker MIL create elif tracker type equals KCF then the tracker will be equal to CV2 legacy tracker key CF create. You can see that we are always accessing the same package. Elif tracker type equals the next one, TLD, then the tracker will be equal to CV2 legacy tracker TLD create. The next one, elif tracker type equals median flow, then the tracker will be equal to CV2 legacy tracker median flow create. Elif tracker type equals the next one is the MOOS algorithm, which is the fastest. Then the tracker will be equal to CV2 legacy tracker MOOS create. And finally, let's move on to the last algorithm, elif tracker type equals CSRT, then tracker equals CV2 legacy tracker CSRT create. And just to make sure that all objects will be created, let's test one by one. The first one is the boosting. The next one, MIL. The information here about the object means that it was successfully created. The next one, KeyCF. We can see this error message because here we need capital letter. That's the first one here, tracker. And let's correct for the other algorithms. Let's run this code again. Now the object was successfully created. The next one, number 3, TLD. Number 4, median flow. Number 5, the MOOS algorithm. And finally, number 6, CSRT. We can see here the message indicating that the object was created. This is the first step to implement object tracking. We are creating different objects according to the algorithm we want to perform the tests. And in the next lecture, we will continue the implementation. See you there!